Hi everyone. With this short presentation, I will discuss some surveys that we are conducting with a group of collaborators, which names are given here, on H-poor Superluminous Supernovae. Before giving you the details of the survey, I will give you some information about what are superluminous supernovae. They are a class of supernovae that have been discovered about 15 years ago. They represent only a very tiny fraction of the supernovae that are detected on a daily basis, and they are 10 to 100 times brighter than other supernovae, like supernova type 1F, for example. They radiate up to 10 to the 51 ergs, and they're most of the time discovered in low mass and metal poor galaxies. And recent works investigated by one of our colleagues in the collaboration shows that two types of classes exist, the double type and the 15BN type. And I will give you more information about this just after. And the best progenitor is a magnetar, which will be a neutron star with a very intense magnetic field, releasing its energy and making these very bright explosions. So the two subclasses I was mentioning, they are the very well-known W type, which is observed before maximum light. This is what we see on the left plot in the pink band. And there is another subclass, which is a 15BN type, which is showing different absorption features in between about 4,000 and 5,000 angstrom. And the differences will be related to the temperature of the photosphere, with the difference between W and 15BN type of about 12,000 Kelvin. And this is intensively studied, as I was mentioning. Why are we interested by superluminous supernovae and polarimetry? It's because we can get information with polarimetries that we don't have with spectroscopy and photometry, basically information about the geometry of the system. So on the top plot, we see the light curve of 15BN, which is a very well-known studied object and which has been well observed in polarimetry. It has been observed that there is a chain of polarization after maximum light, and also when the photosphere is showing some spectral changes. But this type of object is not well. The sample of this type of object is very low. So the aim of the survey is to expand this type of objects and the sample of polarimetry objects. There are only about 10 objects until now. So in the first work, we present data that we got with the Nordic Optical Telescope and Liverpool Telescope on 2020 ZNR. So in this W type, we had a late epoch polarization, which is not showing an increase of polarization. So we are suspecting that W type and 15BN type have different polarization properties. And what will be interesting with LSST is that LSST will capture superluminous supernovae about 4 magnitude deeper than ZTF does, so up to 25 magnitude, in front of 21 more or less now. And so with this, we expect to check. We want to check if the W type, which is showing sometimes early bump, if it is also the case for 15BN. This is not clear at the moment. And now I will give you more insight on the surveys that we are conducting. So we had a first survey in 2021, and the results currently under analysis show that we have another superluminous supernovae 2021 FPL, which is showing apparently polarization properties similar to 15BN. We detected a high level of polarization, 1% after maximum light and after the spectral change of the photosphere as well. And we are currently conducting a second polarization and spectroscopy and photometry survey on new candidates to expand the sample. So thank you very much for your attention.